Okay, students, in last lecture we have discussed about some problems, right? And we have solved that problems by using different formulas. In today's lecture also we are going to do that. We are going to understand some of the problems, right? We are going to make its solutions by different type of formulas, by different formulas like mirror formula, lens formula. We will also take care of the properties of concave mirror, concave lenses, convex lenses, power of lens, and sign convention. Okay, so here we have our first question. A doctor has prescribed a corrective lens of power positive 1.5 diopter. Means here we can say that power of lens is given to us, that is 1.5 diopter, and that is of positively sign. Find the focal length of the lens. We have to find out the focal length of the lens, and the lens which was prescribed by doctor, is it diverging lens or is it converging lens? Okay, very good. Now, first of all, what is given to us? They have given us power of lens. Power of lens P is equal to its positive value 1.5 diopter. Okay, power of lens is given P equal to 1.5 diopter. Now, let's find what we have to do. We have to find out the focal length. So focal length F, we have to find out, and which type of lens is there, that we have to find. It's very easy. We know the formula. Our formula will be P is equal to 1 upon F. So according to that formula we have to find out F. So that's why F is equal to 1 upon P. Okay, good. F is equal to 1 upon, what is power given to us? Its positive value of 1.5, and it is in diopter, right? So if we will calculate this, means here we will have 10 divided by 15. So generally our answer we will get, it will be 0.66. It was in diopter, so here we will have 0.66 meter. If we convert this into centimeter, so focal length F, it will be R 66 centimeter. So focal length of our lens, it will be 66 centimeter. Now, which type of lens it is? First of all, as we know that here our power, it was positive. So our power of lens was positive, which means the focal length F will be also positive. And if the focal length is positive, so this happens only in convex lens. Focal length is positive for convex lens, and convex lens is also called converging lens, right? So convex lens is called converging lens. So simple, this way. Again, I am repeating the question. A doctor has prescribed a corrective lens of power positive 1.5 diopter. So here power of lens is given to us. Find the focal length of the lens. We have to find out focal length F of the lens. And the lens which is prescribed by doctor, is it diverging lens or is it converging lens? So simple, power P is equal to positive 1.5 diopter. Focal length F, we don't know, that we have to find. Simple, we are putting the formula, power of lens P is equal to 1 by F. From that we are making F as a subject. then we will get f is equal to 1 by p. That's why f is equal to power of lens is given 1.5 positively charged, which will be result into 0.66 meter. We can convert it into centimeters, so we will get focal length f is equal to 66 centimeter. As the power of lens was positive, so focal length was also positive, and focal length is positive for convex lenses, right? So as it is positive for convex lens, and convex lens is called converging lens. Okay, so this way we can calculate the sum. Now let's go for the another sum. See, here we are having the another sum. According to this sum, what we can say, a concave lens has focal length of 15 centimeter. We are having a concave lens, right? So keep this in our mind. Concave lens, focal length is given to us. Focal length is our 15 centimeter. So we can say that f is given to us. Focal length f is equal to 15 centimeter. As we have concave lens, so for concave lens our focal length, it will be negative according to sign convention. Okay, at what distance should the object from the lens be placed? Means we don't know the object distance, we don't have value of u, so it forms an image as positive 10 centimeter. So we are having value that is at image at 10 centimeter. But as we know, all of the cases of concave lens, image will be formed at left side, so this image will be also negative. Okay, so this data we have to find out u, at what distance it must be placed. Also we have to find out the magnification produced by the lens. It's very easy. If we can find out u, then it will be very easy to find out its magnification. Okay, let's try. First of all, we are having lens, so we will use lens formula, and according to lens formula, right, what we can say, according to lens formula, it will be 1 over v minus 1 upon u is equal to 1 upon f. We have to find out the value of u. So we can say that 1 upon v minus 1 upon f is equal to 1 upon u. Right, we have taken this term at left side and this term at right side. Now to simplify it, f minus v upon v into f is equal to 1 upon u. We want value of u, we don't want 1 upon u. So from that we can say, so that u will be equal to v into f divided by f minus v. Nothing we have done, we have just done a reciprocal of it. Now from the given data, what is v? Value of v we have, that will be minus 10. Value of f we have, that is minus 15. F minus 15 minus value of v, it will be minus 10. Now let's calculate it. 10 into 150, negative negative, so that will be positive. Here we will get positive 15 0 upon minus 15 minus minus plus 10. So here we will get minus 5. So the answer u we will get, that will be minus 30. The unit was centimeter, so here also we are getting it in centimeter. So our value of u, object must be placed at 30 centimeter, and negative means at left side. So if the object is placed 30 centimeter at left side, then we will get the image at left side at 10 centimeter if the focal length is 15 centimeter. The second thing which we have to find in the sum, that is magnification. Magnification for lens it is. So for mirror we are having minus v by u. For lens we will have only v upon u. Value of v is there, it's minus 10 centimeter. Value of u which we found, it's minus 30 centimeter. Minus minus plus we will get, here we will get 1 upon 3, and by finding answer of 1 over 3 we will get it 0.33, and that is positive. Now this positive sign, it means our image will be virtual and erect. This value 0.33, it is less than 1, so our image will be small, and here you can see that 1/3 means it will be third part, right? So here we can say that image will be diminished, and how much small it will be, 1/3 then object. So our conclusion will be, our image is erect, virtual and diminished. But how much diminished? It's 1/3 than the object. Okay, so understand it again. We have given focal length, that is 15 centimeter. For concave lens it is, so we are taking it as negative according to sign convention. At what distance the object from the lens must be placed, so we don't know what is the object distance, so u that we have to find. V, that we are getting the image at 10 centimeter. So by using lens formula, 1 upon v minus 1 upon u is equal to 1 upon f. By simplifying it, we are making u as our subject. We are placing the values according to sign convention. We are getting value of u, that is minus 30 centimeter. It means our object is placed at 30 centimeter. Negative means at left side from the mirror, sorry, from the lens. Also we have to find out the magnification. So magnification for lens, the formula is m is equal to v by u. So by placing that formula and by placing values in that particular formula, we are getting magnification, that is positive 0.33. Positive sign shows that our image, it will be virtual and erect, and the value which is less than 1, it shows that our image, it will be diminished, it will be small. But as we can see here that m magnification is 1/3, means it is third part than the object. Our image will be third part, 1/3 than the object. So this way we have to calculate different type of sums. Now let's see the another example, right? And this will be the last example which we are going to discuss for this chapter. Rest of the examples, it will be provided you in assignment. So you are going to solve that questions, you are going to solve that sums by your own. In last lecture and in this lecture, we have taken almost all of the types of numerics which can be asked in exam. We have to use little bit of our common sense and we will be able to solve any of question, right? No any question is hard here, but we will be able to solve each and every numeric which is given. Now let's start this. First read it. What it is said. It is said that if we are having a convex lens which forms a real and inverted image of a needle at a distance of 50 centimeter. So here what this 50 centimeter is, the value which is given to us here 50 centimeter, it will show us that 50 centimeter the image is formed. So this will be our image distance. This 50 centimeter, that will be our image distance. Where is the needle placed in front of convex lens? Means we have to find out u. If the image is equal to the size of object. Now see, what does this case means? If the image is equal to the size of object, it means its magnification will be always equal to 1. Keep this in our mind that its magnification will be always equal to 1. The image is real and inverted, so it will be negative of 1. Let's find, and we have to also find out the power of lens. It's very easy. Now let's see what we can do. First of all, what we have the image distance. Image is forming at 50 centimeter, right? So first let's write that image distance V is equal to 50 centimeter and magnification is 1. That means the object must be placed on twice f, right? It will be on twice f. So always the image we will get at a right side. So value of V that we will consider as positive 50 centimeter. Then what we have, then what is given, that the image is real inverted and equal to size. So if image is real inverted, if the image is real inverted and same in size, if the image is real inverted and if it is same. See, real and inverted means in our magnification, real and inverted means it will be negatively signed and same means value will be 1. So from this data we can say our magnification will be equal to -1. For that what we have to find out? So where the needle is placed, we have to find out u. It's very easy. From the formula of magnification we can do. We have lens. So m will be equal to lens. So not minus v by u. For lens it will be only v by u. Magnification it's given -1. V it is given to us, that is 50 centimeter. So u. That's why we know that the value of u will be also equal to negatively sign 50 centimeter. It means our object is placed at 50 centimeter at left side, and we know the cases, we know the image formation, that if the height of image is same, so the distance of image and the distance of object, it will be same only, but it will be in opposite direction. So here the image distance is 50 centimeter. So simple, our object will be also at 50 centimeter, but it will be at left side. So we are getting u, that is minus 50 centimeter. it means it is at 50 centimeter left side from the lens. Now what we have to find, if the image is equal to the size of object, also find the power of lens. Now how we can find out power of lens? Here you can do different in this sum in different way. You can also use the lens formula. As you will use the lens formula, you have value of v, you have value of u, then you can find out value of f by using 1 upon v minus 1 upon u equal to 1 upon f. But instead of that, if we use the characteristics, so we can just compress the sum. I am using the characteristics. What I am doing here, that as we know that this case is only possible if my distance is twice f. Same size we will only get if the object is placed at center of curvature. Right here it is at twice f. So if I am getting the twice f of distance 50 centimeter, again beta, we can also do this by applying lens formula 1 upon v minus 1 upon u is equal to 1 upon f. And if you know the cases, then you will know that the same size is only possible when the object is at r, and we know the relation r is equal to f. So by this we can know the focal length, right? So r means if it is placed at 50 centimeter, then and then we will get the image at 50 centimeter, it will be same in size. So the distance twice f is equal to, we are getting 50 centimeter. So what will be value of f? F will be equal to 50 divided by 2, 25 centimeter. We want power of lens. So power of lens, for that we must require this centimeter into meter. So value of f, it will be a 0.25 meter. Now power of lens P will be equal to 1 over f. Here RF will be positive because we are having convex lens. As we have convex lens, RF will be positive. That's why P is equal to 1 upon 0.25. Here we will calculate and we will get power P is equal to positive 4 diopter. So simple. By understanding the case, you can directly do like this, that r is equal to twice f, and this is only possible that if we have placed the object at r. So by this you will directly get the value of f. Otherwise we can use lens formula, and the lens formula will be 1 upon v minus 1 upon u is equal to 1 upon f. From this we will use to know that the power of our lens, that will be 4 diopter, right, and the object will be kept at left side at 50 centimeter from the optical center O. Thank you. So from this we are going to solve different sums which is provided to you in worksheet or in assignment, right? So just revise the sums of today and the last lecture, so it will give you the concepts, and as you will do more and more practice of the sum, you will get habited of it. Okay, thank you.